The whole area of the square, big square, is 120 centimeters squared. And then we're given lots of different ratios, i.e. we know kind of how the triangles, how the dimensions relate to the square. So what I did originally in this question is I labeled the whole length x, and then I worked, so this would be a half x, for example. Um, but I feel like that's a bit it's overcomplicated. So actually, we know ultimately we just want to find basically the fraction of the whole square that is in these triangles. And so the whole square is going to be 1. So this is a half, and this is a half. Now that we're told that QU is in the ratio 2 to 1, which means this is going to be 2/3 because there's 3 parts in total, and this makes up 2 of them. And this is 1/3. RV is 3 to 1, so that's going to be 3 of the 4 parts. This is worth 3/4, and then this is 1/4. And then 5 parts here. This is going to be 4 of them, so 4/5 of the length and 1/5. All right, and now we can work out the fractions of each of these triangles. So remember, it's going to be still going to use kind of half base times height. So it's going to be a half times 2/3, which is actually just a third, but then we have to halve that. So this triangle represents a sixth of the whole area. If you're not happy with that, then you can revert to what I was saying before. We could make it half x, where the full amount is x. Okay, so this is a half x, and then this would be 2/3 x, because this full amount is x. 2/3 x times 2/3 x, but of course we have to halve it, and that would give 1/6 x squared. So it's 1/6 of the full amount. That's what I mean here as well. Okay, over here I'm going to do 3/4 times a third. But I didn't really explain how I did it before, I just realized. So I can actually just cross cancel those threes. That's how I did it really quickly, which leaves me a quarter, which I still need to times by a half, so I get 1/8. You could do 3/12 and then cancel it down to a quarter, but this is worth knowing. And the reason it works is that basically we're doing 3 times 1/4 times 3, but rather than actually calculating 4 times 3, we can just use the idea of equivalent fractions and cancel it out there. In any case, this is 1/8. Right, let's keep going. A quarter times 4/5 is actually going to be 1/5, and then divide it by 2 or halve it, it's going to be 1/10. It's quite quick. And 1/5 times a half, actually there's no cancelling this time, we get 1/10, and then divide that by 2 or halve it, 1/20. Okay, so the fraction of the area, which is 120 centimeters squared, by the way, that is the triangles, is going to be these added together. Now you could add each fraction one at a time, but better to learn how to add them all in one go. We just need to find the lowest common multiple of all of these numbers. Now, the highest power of 2 is 8. The highest power of 3 is just 3. And the highest power of 5 is 5. So actually, the lowest common multiple is going to be 120. Okay, each of these numbers go into that. That's a little trick you can do. Sometimes you do it like Venn diagrams, or you write them as product of prime factors, but I've done it more quickly here. Okay, we don't, you might be able to look at it, but I don't think it's easy to see that it's 120. So I just want to say it again, like I'm finding a number that all of these numbers go into. So 8 has to go into it, so it has to be a multiple of 8. Okay, it doesn't matter that I've got like a 2 times 5 here. If it's a multiple of 8, it will be a multiple of 2. And then because I've got like a multiple of 5, but only just 5, like not 5 squared or anything, then my lowest common multiple is going to have to be multiple of 5, and the same goes for 3. So that's where that's come from. 12 over 120 plus 15 over 120 plus 6 over 120 plus, what's this going to be? 20 over 120. 27, 33, 53 over 120. So this quadrilateral TUVW is 1 minus 53 over 120ths of the total area. And this could be written as 120 over 120. So we just need to subtract or add on as we need to. 67. 67 over 120 of 120. So that just means we times them. And 67 over 120ths, or 67 120ths of 120 is just going to give us 67. All right. Well done.